We are from Group 2. I'm going to present the worst accident ever happened. Now, let's see an animation about car crash. Among the car crash factors is speeding, rain, and inertia.
How car crash can happen. Speeding. Speeding is the second most common cause of road accidents in the United States. Since car and truck accidents that involve speeding typically occur at high speeds, it's also a major cause of fatal road injuries. Driving above the speed limit is a common practice for many motorists. It's also illegal behavior that vastly increases the risk of losing control of a vehicle and causing an accident. The faster a vehicle travels, the longer it takes to slow down in the event of an obstacle. Even a small increase of speed can result in a much higher risk of being involved in a collision or other type of accident. As such, it's essential for motorists to be aware of the speed at which they're traveling and stay within the legal limits. Next is rain. Believe it or not, rain is one of the leading causes of road accidents in North America. When the road becomes overly wet, cars can lose their grip on the road and slide across the road surface, reducing control for motorists and increasing the risk of an accident occurring. Rain-related driving risks are often amplified by poor car maintenance, such as tires that don't provide a deep enough grip or are improperly inflated. Sometimes, an inexperienced driver can panic in rainy weather, resulting in the loss of control of the vehicle. Because of the safety risks associated with driving in intense rain, it's important to be alert and aware of road conditions, speed limits, and traffic during rainy weather. Distracted driving. Distracted driving is the most common cause of road accidents in the United States, resulting in more crashes every year than speeding, drunk driving, and other major accident causes. Distracted driving is not only the leading cause of car accidents, but it's also true for trucks. Drivers can become distracted behind the wheel for a variety of reasons. Some of the leading causes of distracted driving accidents include using a cell phone while driving, as well as eating food or drinking from a mug or bottle while behind the wheel. Last point is inertia. When the road becomes slippery, especially on winter season, tires or rubbers gaining less friction and may occur accident easily.
How to overcome an accident? First, seat belts on before starting the engine. Second, keep the tire healthy. Third, test the airbags and brakes. Fourth, avoid distraction. Seat belts on before starting the engine. Seatbelts are the primary means of injury prevention in all motor accidents, big or small. Seatbelts attach your body mass to that of a car, meaning that when the car accelerates or decelerates. Keep the tires healthy. Tires can lose approximately 1 pound per square inch of air, PSI, per month. A tire can lose even more in cold weather climates. Test the airbags and brakes. The inflated airbag during an accident acts as a cushion to lessen the impact when the driver flings forward, hitting the steering wheel or dashboard. ABS prevents the wheels from locking when brake applied suddenly by adjust the pressure of brake fluid. This can prevent the car from skidding. Avoid distraction. Pretty much everyone agrees that distract by driving is bad, and the most common distraction just might be your phone. People seem convinced that they must see that notification or status updated now. This can cause problem when you are driving, crash problem.
There are physics theory are related with car crash, such as first force, second energy, third collision, and lastly is Newton.
During a car crash, energy is transferred from the vehicle to whatever it hits. It is either another vehicle or a stationary object. This transfer of energy is depending on the states of motion. The object that was struck will either absorb the energy or possibly transfer that energy back to the vehicle that struck it. This explanation will be focusing on force and energy. We consider a situation which car A collide with a static wall. This situation when car A is traveling at a velocity v and colliding with the wall ending with a velocity of 0. So this force of this situation is defined with the equation of force equal mass times acceleration, which is t is time it takes car A to stop. The car exerts this force in the direction of the wall, but the wall, which is static and unbreakable, exerts an equal force back on the car using Newton's third law of motion. This equal force is what causes car to cording up during collision. In that case of car A, if it slams into the wall and comes to an immediate rest, that would be a perfectly inelastic collision. Since the wall doesn't break or move at all, the full force of the car into the wall has to go somewhere. Either the wall is so massive that it accelerates or moves into the certain amount, or it doesn't move at all, in which case the force of the collision acts on the car. But if we assuming the situation which car collide with a car, we will have a different force consideration. We assuming that car B and C will collide with each other with the same speed but in an opposite direction. So from the conservation of momentum, we know that they must both come at the rest. The mass is the same, therefore the force experienced by car B and C is identical. This explains the force of collision. Kinetic energy is energy an object possesses due to its motion. A vehicle in motion has more kinetic energy than a vehicle at rest. When a vehicle accelerates, it gains velocity and also increases its energy. The kinetic energy of a moving body is equal to Ke, equal to 1 over 2 mv squared, which are m is a mass and v is a velocity. If they are an elastic collision, the kinetic energy is not conserved, but total energy is always conserved. So the kinetic energy will lost in the collision and has to convert into some other form. In the first example, where only car is moving, the energy released during the collision is K. And in the second example, two cars are moving, so the total energy released during the collision is 2K. So we can see that the crash in case B is clearly more than the crash in case A. The car will experience exactly the same force in both cases. The only force that acts on the car is the sudden deceleration from v to zero velocity in a brief period of time due to the collision with another object. However, when reviewing the total system, the collision in the situation with two car release is twice as much energy as the collision with a wall. This is why physicists accelerate particles in a collider to study high-energy physics. The act of colliding two beams of particles is useful because in particle collision, you don't really care about the forces of the particle. You care instead of the energy of the particle. A particle accelerator speeds up particles but does so with a very real speed limitation detected by the speed of light barrier from Einstein's theory of relativity. To squeeze some extra energy out of the collision, instead of colliding a beam of near light speed particle with a stationary object, it better to collide it with another beam of near light speed particle going to the opposite direction, which is same with the case B and C. From the particles standpoint, they don't so much shatter more, but when the two particles collide, more energy is released. In collision of particles, this energy can take the form of other particles, and the more energy you put out of the collision, the more exotic the particles are.
Collision. Car crash involves three types of collisions, such as vehicle collision, human collision, and internet collision. A collision is an event where momentum or kinetic energy is transferred from one object to another. The relationship between kinetic energy and mass is linear, which means that a vehicle massing twice as much has kinetic energy. The relationship between kinetic energy and velocity is exponential, which means that as you increase your speed, kinetic energy increases dramatically. A high-speed car collision is an inelastic collision. Lastly, Newton. Newton's first law of motion explains what happens in a car crash because it basically states that the passenger will continue to travel at the same velocity until an unbalanced force acts on a person. Car crash are clear examples of how Newton's law of motion works. His first law of motion, also referred to as the law of inertia, asserts that an object in motion will stay in motion unless an external force acts upon it. Conversely, if an object is at rest, it will remain at rest until an unbalanced force acts upon it. Consider a situation in which car A collides with a static, unbreakable wall. The situation begins with car A traveling at a velocity and, upon colliding with the wall, ending with a velocity of 0. The force of this situation is defined by Newton's second law of motion. One important aspect of driver training is the development of a safe driving attitude. The reason a safe driving attitude is so important is because you will make many choices as you drive, and the driving choices have consequences. To have a safe driving attitude, you must have control of your emotions and behavior. Practice defensive driving technique and accept responsibility for all of your driving decisions. So, be alert and be smart. Thank you for